Oftentimes, in our modern world, we take the resources we have for granted. It's ironic that we seem to ignore this privilege, while in less abundant areas, there are nations on the brink of war over them. My name is Kellen, and in this video, Noah and I will be covering the Grand Ethiopian Renaissance Dam, discussing its implications for the future of Northern Africa, and reviewing the thermodynamic concepts necessary for its functionality. A dam functions by utilizing water's potential energy by storing and releasing water at separated elevations. This water is then run through a turbine, activating a generator to produce electricity, which is distributed to the grid by a transformer.
The power generated by the Grand Ethiopian Renaissance Dam, as well as its net work, net heat transfer, and hydroelectric efficiency, can be found by modeling an energy conservation equation, as well as a power equation for the turbine. The power generated by the dam can be calculated using P equals rho Q G H, where rho is the density of water, Q is the flow rate of water, G is gravity, and H is the height of the water from the turbine. The energy balance equation states that it is equal to the rate of heat transfer minus the rate of work plus the enthalpy plus the kinetic energy plus the potential energy of the inlet minus the enthalpy plus the kinetic energy plus the potential energy of the outlets. The dam can be modeled as an open system and also as the control volume. By doing so, the system can be assumed to be steady, thus the kinetic and potential energy terms can be neglected. By obtaining temperature and pressure values for the water through experimental measurements of the water, and assuming large reservoirs for constant temperature, enthalpy values can be found using the saturated water tables. A timer could be used with a device that measures volume to obtain an approximate flow rate of the water into the dam. From this, the net work done in the hydroelectric system as well as the net heat transfer in the system can be calculated. Using the formula for power generated by the turbine and a given maximum power value, the ratio of these two values will give the efficiency of the dam.
The energy balance equation Noah detailed is very complex, and real numbers for this equation are rarely measured. Thankfully, we were able to find all the values necessary for the hydroelectric efficiency equation, so we decided to use that to satisfy the real-world example requirement. The annual flow rate of the GERD is averaged at about 50 gigacubic meters of water per year. The annual power produced by the dam is roughly 16,000 gigawatt hours per year. Both these numbers can be simplified to fit more suitable units. The height of the dam is 145 meters. Using these values, we can plug into our original efficiency and power equations to produce an efficiency of about 80%. This may seem high at first glance, but quick search reveals that this is fairly typical for dams. Modern dams can get even as high as 90% efficiency. Why does this matter? Well, the Grand Ethiopian Renaissance Dam began construction on April 2, 2011, and was completed 4 years ago in July of 2020. The purpose of the dam was simple: use the Nile, one of Africa's greatest sources of prosperity, capture its natural kinetic and potential energy, and convert it into usable electricity for Ethiopia's struggling population. Though its construction would not come without controversy. Egypt has laid claim to the entirety of the Nile since it signed a treaty with Britain in 1929, giving it that right. Ethiopia, not beholden to past European colonialism, denied the limitations set by the treaty and went ahead with the GERD's construction in the face of Egyptian complaints. The GERD is located on a particularly vital part of the Nile called the Blue Nile, which lies upstream from the Nile proper in Egypt. The development of the dam on the Blue Nile, Egypt claimed, could interrupt their ability to access clean water, putting their population at risk. 4 years past its completion, Egypt still protests the existence of the dam. President Sisi going so far as saying, "I am telling our brothers in Ethiopia, let's not reach the point where you touch a drop of Egypt's water, because all options are open." Energy production, efficiency, and resource management are important aspects of our life that tend to escape our attention until we hear something on the news, or maybe if prices go up. In reality, these factors are at play constantly, though some feel their effects more than others. We made this video for a few reasons. 1, because it was required for the class. 2, because the thermodynamics applied in an interesting way to the analyzed situation. And 3, because more attention ought to be brought to how others in the world interact with scarcity, so that we might gain a better understanding of the value of what we use frivolously.